I'm Nova.
I'm Alloy, and this is AgentStack Daily.
OpenClaw shipped 6.33 and 6.346 minutes apart, and the pair is almost entirely about making agents harder to trick and less likely to die halfway through real work. Browser routes now reject unsafe access paths, hostile responses get size limits, and long model calls no longer look like frozen processes to the watchdog. Discord and Telegram delivery also recover more cleanly after disconnects. Not glamorous. Extremely useful.
Especially when people are building agents that browse websites without launching a full Chromium process, coding agents that begin with less human oversight, and local image systems that load Minimax H3 from a single file. Today, you'll hear why the terminal-based AI coding agent Claude Code is changing its default, how Cloudflare put an agent browser inside lightweight JavaScript sandboxes, and why GitHub can finally count Claude and Codex activity alongside Copilot usage. OpenClaw 6.33 and 6.34 set an unusually grounded tone, less spectacle, more attention to what happens when software runs unattended.
OpenClaw released 6.33 and then 6.34 on August 8. The first update carries most of the work. Sandboxed browser routes, trusted DNS targets, custom browser origins, and local provider endpoints now reject unsafe access paths. Provider streams, Discord responses, browser fetches, sign-in paths, and logs also cap hostile response sizes. Telegram credentials no longer appear in diagnostics or account addresses, and external tool status output redacts secrets. Gateway HTTP rejects disallowed browser origins before unauthenticated handling, rather than letting a bad origin reach a later stage.
The reliability changes are just as important, because agents increasingly spend a long time inside one model call. OpenClaw now distinguishes an actual stall from active, slow inference when it checks whether a run is alive. Release handling and watchdog behavior won't kill a healthy call merely because the model is taking its time. Retained session rights, provider fallbacks, and streaming progress recover without silently ending active work, while a failure in standard input or output no longer crashes the host process. SQLite checkpoints, workspace reads, process signaling, and plugin web responses also stop turning temporary machine conditions into failed runs. Okay, that's a meaningful upgrade even though nobody gets a shiny new button. It gives existing capabilities a better chance of finishing after a provider pause, a transient machine problem, or one unusually long inference request.
Messaging got the most visible repairs. Discord reconnects preserve queued messages and avoid repeating sends whose outcome was ambiguous. Sustained gateway bursts stay bounded, so a flood doesn't grow forever in memory. Telegram bot-to-bot messages and reply boundaries keep the intended thread, pending channel work resumes after recovery, and acknowledgements can be repeated safely without duplicating their effect. Secret-backed Telegram credentials survive service restarts. Sign-in repair won't overwrite a valid destination profile. External clients connecting through the standard tool protocol on the same machine now receive short-lived, session-bound permission to attach instead of inheriting broader authority from a mutable child process. That's a much narrower trust grant, and it directly reduces what a compromised or confused child process can carry forward.
Approval boundaries tighten too. Codex app server commands require approval from a real person or an authorized plugin. Automatic review of an executable command remains tied to the exact command OpenClaw resolved, and narrow tool permissions remain controlled by the component that created them. Patched production dependencies cover brace expansion, post-CSS, fast URI, IP address handling, and Undici. Then 6.34 closes two specific gaps. OpenCode Go uses the documented Hi3 model name instead of the broken Hi3 preview alias, and Codex native helper agents retain their parent subscription while child agent work is active, until a yielded completion reaches whoever requested it. I like the restraint here. The second release didn't pretend to be a feature event, it fixed two concrete breakages and stopped. Claude Code is about to demand less supervision by default, which sounds convenient and immediately raises a question: what exactly changes when a new session begins?
The terminal-based AI coding agent Claude Code is promoting auto mode to the default for new sessions. Auto mode is the setting associated with fewer human checkpoints while the agent works. People previously had to choose that posture. New sessions will now start there. Developers who already let Claude Code carry longer tasks should see fewer interruptions from the first message. But the default matters most for everyone who doesn't inspect settings carefully, because defaults quietly become normal behavior. The report appeared on August 9th, and the related Hacker News discussion reached 212 points. That attention isn't about a new coding capability. It's about how much authority a coding product should assume before the person using it deliberately grants that authority.
I don't buy the idea that fewer prompts automatically means a better experience. It can be smoother in an isolated project and much more consequential in a production repository, where an action may modify files or trigger connected systems before someone pauses to inspect it. Anthropic is moving autonomy from an opt-in preference into the initial posture. That flips the burden. People who want more checkpoints now have to choose them, instead of people who want greater autonomy choosing that. And coming right after OpenClaw tightened exact command approvals, the contrast is sharp. One product is narrowing where unattended actions can travel, the other is reducing how often new sessions stop to ask.
Cloudflare introduced Kitesurf on August 7th, a cloud-hosted browser built for AI agents rather than people. Instead of starting a full Chromium process whenever an agent needs to visit a page, submit a form, or collect information, Kitesurf runs in V8 isolates. Those are lightweight JavaScript sandboxes of the kind used by Cloudflare workers. They can start in milliseconds and share an underlying runtime, while ordinary headless browsers carry a complete browser process with substantial memory and processor overhead. At thousands of concurrent sessions, that difference isn't cosmetic, it changes the cost of browser automation. Cloudflare is targeting the jobs where software needs to interact with a web page but doesn't necessarily need every human-facing part of a desktop browser.
Okay, that's actually exciting, because browser agents have inherited a lot of machinery intended to draw pixels for humans. Cloudflare says Kitesurf uses less computing power than Chromium for common automation jobs. That number-free comparison comes directly from Cloudflare, so it's a claim until outside users publish measurements. Still, the design makes sense. Remove expensive human rendering work when the customer is software. The launch drew a Hacker News score of 217, which tells you developers recognize the pressure. Every agent that opens headless Chrome adds memory and processor overhead, and multiplying that across many users can make the browser layer one of the expensive parts of an otherwise straightforward workflow.
But browser is doing a lot of work in that name. A lightweight runtime can be dramatically cheaper while still facing compatibility limits on complicated pages. Cloudflare's announcement establishes the runtime design and intended uses, not universal equivalence with a complete human browser. Kitesurf is positioned for web page visits, forms, and data collection. That's useful. It doesn't prove every browser workflow can move unchanged, and it doesn't tell us how it handles every site that relies on obscure rendering behavior or aggressive automation defenses. GitHub's Copilot Usage Metrics API now includes activity from agent applications such as Claude and Codex when they run inside GitHub workflows. Those partner agents already operated in repositories and pull requests. What changed is visibility. Their activity can now appear beside human Copilot usage in the reporting system administrators already query. That closes a surprisingly basic reporting gap. Organizations could allow agent work but couldn't see it in the same usage view as the Copilot activity surrounding it.
And that matters because one reporting call can now show how often those agents are being used across an organization instead of leaving their runs outside the main Copilot view. An administrator may be able to spot rising adoption, spending drift, or repositories where agents have become major contributors. GitHub's changelog is brief, though. It doesn't provide new field names, endpoint details, or a confirmed per-agent breakdown. So we know agent app activity entered the metrics layer. We don't know from this announcement whether someone can cleanly compare Claude with Codex. Even so, accounting has caught up with capability. Once agent work becomes measurable beside seats and Copilot use, it becomes much harder to treat that work as an invisible experiment.
There's also a governance consequence that isn't abstract. A team can have agents opening pull requests or working through repository tasks while central administrators see only conventional Copilot numbers. Bringing those runs into the existing reporting surface makes organizational adoption visible without requiring a separate log collection project. It won't answer whether the generated work was good, safe, or worth the money. Usage metrics aren't quality metrics. But they establish the denominator. Before anyone can compare outcomes or costs, they need to know how often each class of tool is being used.
GitHub also shipped a Copilot weekly update across desktop, the command line, and VS Code on August 3rd, with the changelog posted August 7th. Is there a real feature here, or just a broad theme?
Broad theme. GitHub describes 3 areas: resuming and organizing work, reviewing changes, and asking questions without losing context. The supplied changelog doesn't identify feature flags, model changes, version numbers, or the technical implementation. So the honest description is a continuity-focused update across Copilot's 3 main surfaces. GitHub wants work left in one place to be easier to resume and organize, while review and question flows retain relevant context. The announcement doesn't establish seamless movement of one session across every client, and it doesn't say a new model or setting produced the change. That's thinner than the Kitesurf post, but continuity is becoming a competitive feature. Coding agents aren't limited to one prompt in one editor anymore. Work may begin in VS Code, continue through a command line surface, and get reviewed in a desktop application. Losing the thread between those moments wastes the very time the agent was meant to save. GitHub says it improved that experience, but doesn't give enough detail to measure the improvement from the announcement alone. So, a shipped multi-surface update, a clear direction, and no excuse to invent mechanics the changelog didn't provide. A community repack of Minimax H3 is climbing Hugging Face. Rail Rebelli's Minimax H3 GGUF repository appeared on August 3rd and has roughly 174,862 downloads and 191 likes. GGUF is a container commonly used to package quantized models, weights represented with fewer bits so they need less memory, usually with some possible loss of fidelity. The repository points back to ComfyOrg's Minimax H3 and carries a Comfy UI tag, aiming it directly at the node-based interface many people use to assemble local image generation workflows. Rather than changing the underlying model, the publisher changed how people can obtain and run it.
That's fast adoption for a repack, but I want to separate convenience from novelty. The publisher didn't introduce a new base model, it wrapped an existing checkpoint for a local toolchain. That bridge can still matter enormously. Packaging determines whether someone can use a model on a home GPU or has to wrestle with formats and hosted infrastructure first. GGUF is strongly associated with llama.cpp and Allama in local text model circles, and its use here shows that the appetite for smaller, easier artifacts is spreading through image workflows. A model can be technically available for weeks and still feel inaccessible until someone packages it for the software people already run.
The license is where enthusiasm needs a break. This repository lists its license as unknown, which is distinct from whatever license applies to the original checkpoint. A quantized artifact can be technically convenient while its redistribution terms remain unclear. The download count tells us people are pulling it. It doesn't settle whether they can safely redistribute it inside a product. Still, the immediate change is concrete. Local Comfy UI users now have a Minimax H3 family package aligned with consumer hardware rather than a cloud-only backend. That's why repacks sometimes move faster than model announcements. They meet people where the software already runs, even when the legal packaging hasn't caught up with the technical packaging.
Amazon is planning a dedicated power plant on the grounds of a new Texas data center, and the New York Times frames that plant as being on track to become the largest single source of climate pollution in the United States. That's a staggering title for one facility. Why put the generator directly at the site?
Because on-site generation can bypass grid interconnection queues and capacity bottlenecks. The plant is described as the data center's primary supply, not a backup generator waiting for an outage. That lets the project secure energy for a hyperscale computing campus without depending entirely on regional grid expansion. It also concentrates the emissions in one identifiable point source rather than drawing from a broader utility mix. The report was surfaced by TechCrunch's AI desk, and the Hacker News discussion reached 234 points. The attention reflects two connected questions: whether power infrastructure can keep up with AI demand, and what companies will build when it can't.
And this is the bill hiding behind the lightweight browser conversation. Kitesurf tries to shave computing cost from each browser session. A campus-scale project answers scarcity by putting a power plant next door. Those are radically different responses to rising machine workloads. On-site generation may accelerate construction, but it doesn't make pollution disappear, it makes the source easier to locate. Texas permitting will matter, as will whether other hyperscalers copy the template for training and inference campuses.
The supplied facts don't establish final emissions, fuel mix, approval status, or an operating date, so on-track matters. But the proposed scale is already consequential. If AI facilities increasingly secure private generation because the grid can't connect them quickly enough, data center companies won't merely buy electricity. They'll help determine which plants get built, where pollution lands, and how long that generating capacity may remain in service. That's a much bigger footprint than renting more servers. OpenAI published preliminary cybersecurity evaluations for Astra on August 7 and said it's strengthening safeguards and security controls around what it calls the next frontier of critical cyber capabilities. The post confirms structured cyber work is underway. It does not disclose the test categories, attack surfaces, outcomes, or concrete controls. In other words, OpenAI has announced the evaluation effort without supplying enough evidence for outsiders to judge Astra's cyber capabilities or the strength of the safeguards.
So this is a disclosure of activity, not evidence that Astra passed a meaningful bar. The Hacker News thread reached 204 points, which shows real interest, but the post's thinness matters. Preliminary evaluations can cover a wide range of rigor, and OpenAI hasn't supplied numbers that outsiders can interpret or reproduce. Still, publishing while work is underway creates an expectation of follow-up. If later reports name the capabilities examined, safeguards applied, and results, people can judge movement over time. For now, Astra is receiving structured cyber evaluation and OpenAI has chosen to discuss that work only at summary level.
I'd also separate capability testing from safeguard testing. A model might demonstrate stronger cyber performance while controls reduce how easily that performance can be misused, but the current summary doesn't quantify either side. That distinction will matter if OpenAI later claims progress. Without named checks, a baseline, and reported outcomes, strengthening remains the company's description of its work rather than a measurable result. The publication is still notable because it places cyber evaluation on Astra's public record before a more complete report arrives.
A new open-weight agent called Fisher R1-14b targets an uncomfortable research problem. An AI can run statistical code correctly and still make an invalid claim about what the result means. The researchers built pbench, 425 realistic hypothesis testing tasks across economics, biology, and medicine, to catch cases where assumptions behind an analysis don't fit the data.
Fisher R1 was trained on synthetic tasks with rewards for statistically valid answers, not merely completed calculations. The researchers report roughly 21% higher single-trial success across pbench than GPT 5.4 and DeepSeek V4 Pro. That's their result until independent work reproduces it, but the distinction is valuable. Producing a p-value isn't the same as checking whether the data justifies that test or conclusion. An AI scientist that misses that difference can generate polished nonsense at machine speed. ResidencyRL trains clinical agents through simulated appointments lasting as many as 60 dialogue exchanges. The simulated patients can resist, mislead, or conceal symptoms. Agents are scored on diagnosis, safety, communication, and whether they catch dangerous warning signs rather than simply naming a likely condition.
Okay, this one has a result worth pausing on. The researchers report a 31% reduction in missed red flag symptoms against a baseline, with blinded clinicians preferring the trained agent in most direct comparisons. Performance also transferred to a separate clinical benchmark, suggesting the training wasn't confined to one test. Those are research results, not proof of safe clinical deployment. But difficult simulated conversations better resemble what doctors face: incomplete information, changing answers, and a patient who may not volunteer the crucial detail. DeepSeek's v2026.7.33 has reached roughly 954,000 downloads and almost 3,000 likes since its July 31 publication on Hugging Face. Is Flash telling us anything solid about its capabilities?
Only what the name and repository positioning support. It's presented as a lighter v4 family model for text generation and conversation rather than the family's heaviest reasoning option. It ships as Saphotensors, a weight format designed for safer and efficient loading, and carries the Transformers tag, so it fits standard Hugging Face software without a conversion step. The repository also lists 8-bit support and compatibility with hosted endpoints. Those details lower integration friction. They don't tell us the memory requirement, context length, speed, or how well it performs in a particular agent workload. That's an important boundary because Flash is a product label, not a benchmark.
The MIT license is the genuinely notable part. It permits broad use, modification, and redistribution with relatively few conditions, which makes the weights attractive for local assistants, fine-tunes, and commercial products. The repository carries an evaluation results tag, but the supplied material doesn't include individual benchmark scores. So we shouldn't turn a tag into a victory lap. Nearly 1 million downloads does show interest, though, and a permissive license can accelerate the cycle from release to community adaptation. People can package it, alter it, and put it behind products without navigating a custom license for every use.
I'd resist treating popularity as quality, too. Downloads can include repeated automated pulls, and the Hugging Face count doesn't prove v4 Flash beats larger siblings in tool use or sustained agent work. Independent comparisons are still missing. What has shipped is straightforward: an open DeepSeek conversational model, in familiar formats, under MIT, with enough early traction to become a meaningful local and hosted option. That combination can matter even before a benchmark winner emerges, because compatibility and permission often determine which model gets adopted into real software. Comfyorg's Minimax H3 repository has passed 6 million downloads and sits around 1,107 likes. It's identified as a fine-tune of Minimax AI's Minimax H3 and tagged for both Comfy UI and single-file diffusion. That last phrase means the diffusion checkpoint is packaged as one self-contained file rather than split across multiple weight shards and configuration pieces. For people already using Comfy UI's node-based visual workflows, the packaging is designed to fit an established way of assembling image generation systems.
6 million is the number that makes you look twice, but one-file delivery explains part of the appeal. Comfy UI users can place a checkpoint into an existing workflow instead of reassembling a fragmented release. For an agent system that needs an image generation branch without sending every request to a hosted service, that removes packaging friction. It doesn't make the model small, fast, or suitable for every machine. The supplied details don't establish any of those things, but it makes the artifact easier to move and load. Sometimes distribution wins because it removes one annoying step, not because the underlying model suddenly became smarter.
The listed license is other, so the repository isn't making a simple MIT-style commercial promise. And because this is a fine-tune rather than a model trained from scratch, its behavior remains connected to the parent Minimax H3 family. The concrete news is the adoption and packaging. A Minimax H3 fine-tune aligned with Comfy UI has become a heavily pulled, single-file artifact.
It also clarifies why the earlier quantized community variant exists. Comfyorg made the model convenient for the workflow. Real Rebel tried to make it convenient for more constrained local hardware. Those are separate distribution layers around the same family. One reduces file and configuration complexity. The other lowers numerical precision to reduce memory demands. Neither is a new base model, but together they show how quickly an open model can acquire the formats needed for broader local use.
Multiverse Computing CAI published a Hugging Face post on August 10 arguing for a cheaper route to knowledge distillation at scale. Knowledge distillation trains a smaller model to imitate a larger teacher, aiming to retain useful behavior while reducing inference cost. That can be valuable when one narrow job repeats often enough that running the largest available model every time becomes wasteful.
Cheaper sounds great, but cheaper by how much? The supplied evidence doesn't say. There are no benchmark numbers, parameter counts, cost figures, or named techniques in the available material. So the word belongs to the publisher, not to a quantified result we can compare. The subject still matters because distillation can move useful behavior into a model that's faster or less expensive to serve. A specialized support model, classifier, or domain assistant doesn't always need the full teacher at inference time.
And scale is where the economics become interesting. Generating teacher outputs, selecting examples, and training the student can itself be expensive, so any method that genuinely reduces that cost could widen access to custom models. But the post details provided here don't show which part became cheaper or whether quality held steady. For now, it's a newly published direction and claim, not a demonstrated cost breakthrough. More evidence would need to connect the lower expense to retained capability.
Intel appointed Dean Jarnac as Executive Vice President and Chief Sales Officer on August 7. He'll lead the company's global sales organization across client computing, data centers, AI, networking, and custom chips. That's a wide portfolio. Does the appointment tell us anything concrete about the products?
Not about product performance. The change is organizational, not a new processor or AI system. Intel says the appointment is intended to strengthen customer relationships and sales execution across that portfolio. The announcement doesn't provide evidence of compatibility, deployment improvements, or technical roadmap changes, and those shouldn't be inferred from a leadership hire. It does show where Intel wants executive attention, translating products including AI accelerators and custom silicon into customer commitments across several markets.
That matters in a market where technical roadmaps and supply aren't enough. Customers making data center decisions need confidence that products will arrive, integrate, and remain supported. A chief sales officer can influence those relationships, negotiate large commitments, and shape how Intel presents its offerings against rivals. But one appointment doesn't demonstrate growth by itself. We'll need customer wins and business results before accelerate growth becomes more than Intel's stated objective.
The AI connection is therefore commercial rather than technical. Intel is trying to sell into a market where buyers are making expensive, long-lived infrastructure choices, sometimes including custom silicon and entire data center deployments. Jarnac's remit puts those conversations under one global sales leader. It may change how the company coordinates accounts across client, network, and data center products, but the announcement doesn't establish any immediate change for software running on Intel hardware. HKUDS's Nanobot is the traction leader at 46,820 stars. Its 0.3 release arrived July 25, and the repository was updated August 10. It's a self-hosted Python agent framework with a web interface, tools, memory, multi-agent workflows, automation, chat applications, and MCP support. MCP is the common protocol agents used to discover and call external tools. Nanobot can expose that tool surface directly, perfects fast MCP, at 27,149 stars with release 3.4, approaches the other side by making MCP servers and clients easier to build in Python.
Data's Codebase Memory MCP connects those ideas to software work. At 38,358 stars, its 0.9 release indexes code into a persistent knowledge graph, a linked map of files, symbols, and relationships across 158 languages. The project claims millisecond indexing for an average repository, queries under a millisecond, and 99% fewer tokens. Those are repository claims, so I wouldn't bank the savings until independent measurements arrive. It ships as one static executable. Put all three together and you get an agent framework, a memory service specialized for code, and a Python toolkit for exposing both kinds of capability through the same tool protocol.
That's why these projects fit together better than three isolated star counts. Nanobot supplies the agent environment, Codebase Memory MCP supplies a structured view of a repository, and FastMCP helps turn capabilities into callable services. Their recent releases 0.3, 0.9, and 3.4 also show work continuing across each layer. Model progress landed through packaging, adoption, evaluation, and domain-specific training rather than a newly arrived general-purpose name from major hosted providers. DeepSeek v4 Flash and the Minimax H3 ecosystem supplied the movement, familiar local formats, permissive or repository-specific licensing, and artifacts shaped for software people are already using.
DeepSeek v4 Flash 0731 is the local spotlight, a text generation and conversational model with about 2,995 likes and 954,441 downloads. It ships in SafeTensors format, works with the Transformers ecosystem, includes an 8-bit tag, and carries an MIT license. The repository also identifies evaluation results and compatibility with hosted endpoints.
That's an unusually reusable combination: standard loading tools, lower precision support, and broad permission to modify or redistribute. But the supplied material doesn't state context length, hardware needs, or detailed benchmark outcomes. Flash suggests the lighter member of its family. It isn't a substitute for measured latency or quality. What people actually have is a widely adopted DeepSeek checkpoint for conversational systems and fine-tuning work that doesn't require unusual conversion or a restrictive custom license. Laravera's Minimax H3 Turbo LoRa is an adapter for text-to-video, text-to-audio, and combined audio-video work in Comfy UI. It has 574 likes but no recorded downloads. Ethanfal's Quen 3VL32B Ultra Heretic H3 Comfy UI INT8 Convrot also shows no downloads. It's an 8-bit image and text model variant with 426 likes. Both show aggressive community adaptation around multimodal Comfy UI workflows, although their recorded adoption remains early.
Baidu's Unlimited OCR is much further along, roughly 2.9 million downloads and 3,995 likes. OCR means optical character recognition, turning text and images into machine-readable content. It's a vision language model tagged for transformers, SafeTensors, feature extraction, and custom code. That traction makes document extraction the mature item of the three, while the Minimax and Quen variants point toward experimentation across generated video, audio, and visual understanding.
For the primary sources, model pages, project repositories, and supporting details, look at the show notes at tobyonfitnesstech.com.
Thanks for listening to AgentStack Daily. We'll be back soon.